Hey everyone, and welcome back for another deep dive. Today we are going to be looking into something pretty interesting, AI hardware accelerators.
Ooh, exciting.
Yeah, and specifically we're going to be talking about Groq and their language processing unit, or the LPU.
The LPU, yes.
Srinikata put this research together, and I got to say, uh, the more I read about Groq and the LPU, the more I was just like, wow,
It's really
this
cool.
is kind of a big deal.
It is a potential game changer for sure. And what's really interesting is that Groq was founded by ex-Google TPU engineers.
Oh wow. Okay, so
They have a pedigree.
this is like the real deal. This isn't just like some,
Yeah.
fly-by-night company.
No, not at all.
This is
This is serious
some
stuff.
serious engineering.
Yeah. And, they're not to be confused with Elon Musk's Groq LLM.
Oh, right, right.
It's a totally different Groq.
Different crock.
Yeah.
So our mission today is to unpack what this LPU is all about, how it's different from, other AI hardware, and why it matters. Okay, so let's dive in. So to start off, can you give us a little bit of background on Groq and the LPU? Like, what is it? How did it come about?
Sure. So as I mentioned, Roque was founded in 2016 by Jonathan Ross, who was actually a former engineer on the GoNS TPU project.
Oh, wow.
And the LPU itself, it stands for Language Processing Unit, and they designed it specifically for large language models from the ground up.
Okay, so it's specifically made for LLMs.
Yeah, exactly like ChatGPT or Bard.
Interesting.
Yeah, and one of the key things about Groq and their approach is this idea of being software first, which is kind of a different way of thinking about hardware design.
Okay, software first. What does that even mean when we're talking about hardware?
So traditionally, you design the hardware and then you figure out the software.
Right.
But Groq, they said, no, we're going to start with the software and then we're going to design the hardware to perfectly execute that software.
Oh, so they're like optimizing the hardware for
Exactly. It's like, if you were building a car, you would design the engine to work perfectly with the transmission and the wheels.
I see.
So everything is in sync.
That makes sense.
And this results in something they call a programmable assembly line architecture.
Okay, programmable assembly line. Break that down for me.
Imagine an assembly line where every step of the process is pre-planned and scheduled.
Okay.
You know exactly what's going to happen when and where.
Like a well-oiled machine.
Yeah, and that's how the LPU works, essentially.
So no bottlenecks.
Exactly, no bottlenecks. Everything flows smoothly.
So how does this translate to like actual performance benefits when we're talking about LLMs?
Well, one of the big advantages is something called deterministic computing.
Deterministic computing. That sounds...
It sounds complicated, but it's actually a very simple concept.
Okay.
It basically means that, the exact timing and location of every instruction beforehand.
So there's no guesswork.
No guesswork. And this translates to predictable latency and performance,
Okay.
which is a huge deal for LLMs because
Because you need that speed.
you need speed, you need consistency. You don't want your chatbot to be lagging or giving you different responses every time you ask it the same question.
Right, right.
And on top of that, Groq has incorporated a ton of on-chip memory into the LPU.
Oh, wow.
So instead of constantly going back and forth to external memory, which can be a major bottleneck,
Yeah.
the LPU keeps more data close at hand, making data access much faster.
Oh, so it's like having everything you need
Right there.
right there at your fingertips.
Right at your fingertips.
So it sounds like this LPU is pretty fast.
It's extremely fast. And because of its efficiency, it's also potentially more energy efficient than GPUs, which are traditionally used for LLMs.
Oh, so it's not just about performance. It's also about
Sustainability.
sustainability.
Yeah.
Interesting.
Yeah.
Okay, so we've got this super efficient, super fast, super predictable LPU for LLMs.
That's the LPU in a nutshell.
It sounds like they've kind of cracked the code.
It's a very promising technology for sure.
Yeah, but before we get ahead of ourselves, we should probably clarify that the Groq LPU is not a photonic solution,
Right.
like we've talked about with light matter.
Exactly.
It's still based on electronic chip technology.
That's correct. Yeah. It's all about optimizing the electronic architecture for language models.
Okay, so Groq is focusing on electronics, while light matter is venturing into the world of photonics.
Exactly. It's two different approaches to solving the same problem.
Okay, so different approaches, but both aiming for that,
High performance, low latency AI.
that next level.
Yeah.
Okay, so for our listeners out there who might be thinking, okay, this LPO is cool and all, but why should I care?
That's a great question.
Like, why does this matter to me?
Well, the truth is you're already interacting with LLMs more than you realize.
Really?
Yeah, think about every time you use a search engine or you get a personalized product recommendation,
Whoa.
you're interacting with an LLM.
I see.
And the LPU is designed to make those interactions lightning fast. So it's about making your online experience smoother and more responsive.
So it's not just about, theoretical performance. It's about actually improving the AI applications that we use every day.
Absolutely. It's about making AI more accessible, more useful, and more enjoyable.
Okay, so it's making our digital lives better.
Exactly.
Can you give us some like real world examples where this low latency and efficiency really make a difference?
Sure. Let's say you're on a website and you need help with something, so you start chatting with a customer support chatbot.
Right.
Now, thanks to the LPU, that chatbot can give you quick, relevant answers without any of that frustrating lag or delay.
Oh, so no more waiting like 5 minutes for the chatbot to respond.
Exactly. It makes the whole experience much smoother and more efficient.
Okay, that makes sense.
What else? Another example is content recommendation systems.
Oh, yeah.
You know those algorithms that suggest videos or articles that you might like?
Right.
Well, the LPU can make those recommendations happen in real time based on your latest activity.
Oh, wow.
So it's about making the online experience more personalized and engaging.
It's all about making our digital lives faster, smoother,
Yes.
more responsive. And let's be honest, we all want that.
Absolutely.
But we also have to talk about the elephant in the room, energy efficiency.
Right.
These AI models can be real energy hogs.
Yeah, they can be very power hungry.
So how does the LPU address that?
Well, the LPU is designed to be remarkably energy efficient, and this translates to lower operating costs, which is great for businesses,
Yeah.
and a smaller environmental footprint, which is good for everyone.
So it's a win-win.
Absolutely, it's a win-win.
Okay, so it's not just about performance, it's about sustainability too.
Exactly.
Okay, so we've established that Groq and their LPU are making waves in AI hardware. But there's one more giant we need to address.
Who's that?
NVIDIA.
Ah, yes. The 800-pound gorilla.
Yeah, they're the current kings of AI computing, particularly with their GPUs.
Yeah.
So where does Groq fit into this landscape? Are they going head-to-head with NVIDIA?
It's not really a head-to-head battle. NVIDIA has built an amazing ecosystem over the years with hardware, software, and a huge developer community.
Right.
So it's a tough act to follow.
So it's not about dethroning NVIDIA.
Not exactly. Groq is carving out a specific niche in the AI market, focusing on high-speed and efficient inference for LLMs.
Okay.
They're not trying to be everything to everyone.
I see.
Think of it like a master chef with a set of specialized knives. Each knife is perfect for a particular task.
Right.
NVIDIA's GPUs are still incredibly versatile, but Groq's LPU is the ideal tool for this specific job.
So there's room for both NVIDIA and Groq in this evolving AI landscape.
Absolutely. It's about having different tools for different jobs. As businesses rely more and more on LLMs, they'll need specialized hardware to support them, and that's where Groq comes in.
Okay, I'm seeing the bigger picture here. It's less about competition and more about creating a diverse toolkit for the AI world.
Exactly.
And speaking of tools, we've talked about Groq's electronic approach and Light Matter's photonic computing. How should enterprises decide which path to take?
Well, it all comes down to their specific needs. If a company is heavily invested in LLMs and needs incredibly low latency for massive amounts of requests, Groq's LPU is the way to go.
Okay.
They're all about speed and efficiency when it comes to large language models.
That makes sense, but what about Light Matter? When would their photonic approach be a better choice?
Light Matter is playing the long game. Their focus is on the advantages of light for computation, especially when it comes to handling the ever-increasing volume of data we're generating.
Right.
They're looking at long-term scalability for bandwidth and power efficiency.
So Groq for immediate high performance needs Light Matter for long-term scaling. It sounds like the AI hardware landscape is becoming more and more diverse.
It is. It's a very exciting time to be in this field.
Yeah, which is pretty exciting. But let's bring it back to reality for a moment for business leaders out there.
Yeah.
Is new hardware, like the LPU, essential for successfully adopting AI?
That's the question everyone's asking, isn't it?
Yeah.
And the answer, like most things in tech, is it depends. Not every business is going to need an LPU. But for those whose operations depend on LLMs, it could be the difference between struggling to keep up and thriving in a world driven by AI.
So if LLMs are the heart of your AI strategy, the LPU is the circulatory system that keeps everything running smoothly.
Exactly. Think about things like search document summarization, even customer support, as These processes become more reliant on LLMs. The hardware supporting them becomes just as important as the models themselves.
Right.
And as those models become larger and require real-time responses, specialized hardware, like the LPU becomes increasingly crucial.
Okay, it's not a one-size-fits-all solution, but for businesses heavily invested in LLMs,
Hmm,
the LPU is a game changer.
I think so.
But I'm curious, how did Groq come to be? You mentioned they were founded by ex-Google TPU engineers. Is there more to that story?
Absolutely. Jonathan Ross, Groq's founder, was actually a key architect behind Google's TPU.
Yep.
He and his team saw the rising potential of LLMs early on and recognized that traditional hardware just wouldn't be able to keep
So
pace.
they were at the forefront of LLMs
Yeah.
and knew they needed to build something completely different.
Precisely. And that's the origin story of the LPU. It's really a testament to their vision and deep understanding of the challenges and opportunities presented by LLMs.
It's amazing how their experience at Google directly shaped the creation of Groq. It's
Yeah.
like they took the lessons learned from building one of the most advanced AI processors in the world and said, we can do even better.
And that's what makes this entire field so dynamic. It's all about pushing boundaries and finding new ways to solve complex problems.
Speaking of pushing boundaries, we've spent a lot of time talking about Groq and the LPU, but they're not the only players in this game. What other companies are making waves in the world of AI hardware, which we'd be keeping an eye on?
There's a lot happening in the world of AI hardware. You have established companies like Intel and AMD who are heavily investing in this space, but then you also have this wave of startups coming in with specialized chips for all sorts of AI tasks.
So it's even more specialized than what we've seen with Groq and light matter?
Absolutely. We're talking about chips designed for everything from natural language processing to robotics, computer vision, autonomous driving. It's an explosion of innovation.
Wow, it's becoming an ecosystem of its own. But with so much going on, it can be tough to see the forest for the trees. What are some of the key trends emerging in this landscape? What's the big picture?
One of the biggest trends is this shift towards domain-specific architectures. Instead of relying on general-purpose processors like CPUs and GPUs forever, we're seeing chips designed specifically for certain types of AI workloads.
So it's all about finding the right tool for the right job.
Exactly. This specialization allows for amazing breakthroughs in performance and efficiency. We're talking about AI models that were previously unimaginable, and now they're running on less power and at a lower cost.
That's incredible. It feels like we're on the verge of a major transformation in how we build and use AI, but with all this focus on specialized hardware, I'm wondering about the software side of things. How does this impact the development and deployment of the actual AI algorithms?
It's a great question. As hardware becomes more diverse, software needs to adapt as well. We're seeing new programming languages, libraries, and platforms specifically designed to work with these new AI chips.
So it's not just about the chips themselves, but about building a whole software ecosystem around them.
It's a two-sided coin. Hardware and software need to work together in harmony if we want to unlock the true potential of AI.
That makes a lot of sense. It's not just about individual pieces, but about how they all connect and work together. Okay, we've talked about Groq,
Yeah.
LPU, light matter, domain-specific architectures, a whole shebang, but what does this all mean for the future of AI? What are the implications of this hardware revolution?
That's the million-dollar question. I believe we're entering a new era of AI, one that's marked by both incredible power and incredible specialization.
So it's not just about making AI bigger and faster, but about making it smarter and more tailored to specific tasks.
Exactly. And I think this is going to have a profound impact on every aspect of our lives. We're going to see AI being used in ways we can't even imagine today, powered by these new and powerful hardware platforms.
That's a thrilling thought, but also a little daunting. It raises questions about accessibility and control. As AI becomes more powerful and specialized, who will have access to it, and how do we ensure it's used responsibly?
These are crucial questions and ones we need to address right now. The development and deployment of AI need to be guided by a strong ethical framework with a commitment to transparency and accountability.
So it's not just about the technology, but about the values that shape its development and use.
Absolutely. We need to make sure AI is a force for good, benefiting all of humanity, and with that in mind.
I think it's a good point to pause our deep dive for now, but don't go anywhere just yet. In part 2, we'll uncover even more insights about Groq the LPU and what this all means for the future of AI. See you soon.
Welcome back. Glad to have you with us again as we continue this dive into Groq and the LPU.
Yeah, I'm excited to keep going. We were just starting to get into like the really big picture stuff. Yeah.
Absolutely. And there's one more detail about Groq's approach that we should definitely touch on.
Okay, lay it on me.
It's something that Srini Kata highlighted in his research, and it's kind of a hidden gem.
Oh, I love those.
Remember how we talked about deterministic computing?
Yeah, where like every instruction is pre-scheduled.
Exactly. Well, it turns out that this predictability actually has some surprising security implications.
Wait, really? How does that work? I don't quite see the connection between predictable execution and security.
Okay, so think about it this way. In traditional computer architectures, there's a lot more variability in how instructions are executed,
Okay.
like tiny little variations in timing or sequence.
Okay, I'm following.
And these tiny variations, they can actually create opportunities for hackers.
Oh, I see.
They can exploit these little inconsistencies to gain access to systems or data.
So it's like finding those little cracks in a wall.
Exactly. They're looking for those weak points. But with the LPU, everything is so tightly controlled and predictable that there are far fewer of those cracks for attackers to exploit.
Well, that makes sense. So the LPU is like a fortress with no weak points.
That's a good way to put it. And this is becoming increasingly important as AI systems become more interconnected and, integrated into critical infrastructure.
Security is more important than ever.
Absolutely. It can't be an afterthought. It needs to be built in from the ground up.
I totally agree. Okay, so that's a huge advantage for Groq. But let's shift gears for a moment and talk about adoption. We've established that the LPU has a lot to offer, but are businesses actually using it? Are there any real-world examples of companies putting the LPU to work?
Oh, absolutely. We're seeing the LPU being adopted across a wide range of industries, from finance and healthcare to retail and manufacturing.
Well, okay, so give
Well,
me the inside scoop.
yeah.
How are companies actually using the LPU? Like, what problems are they solving with it?
One area where we're seeing a lot of traction is in financial services.
Okay, makes sense.
Companies are using the LPU to power fraud detection systems that can analyze massive amounts of data in real
Oh,
time.
wow. So it's like having a superpowered security guard constantly watching your financial transactions.
Exactly. And because the LPU can handle these complex calculations so quickly and efficiently, these systems can be much more proactive and effective.
They can like stop fraud before it even happens.
Precisely. It's all about staying one step ahead of the bad guys.
That's pretty impressive what other industries are jumping on the LPU bandwagon.
Another great example is healthcare.
Okay.
The LPU is being used to speed up the analysis of medical images like X-rays and CT scans.
Oh, wow.
This can help doctors make faster, more accurate diagnoses, which can be literally life-saving.
Yeah, no kidding. So we're talking about potential breakthroughs in medical treatment.
Absolutely. And we're even seeing the LPU being used for things like natural language processing and machine translation.
Oh, really? So it can help us understand each other better.
Exactly. It's breaking down language barriers.
That's amazing. So the LPU is a pretty versatile tool.
It's incredibly versatile. And as the technology continues to evolve and more companies see its potential, I think we'll see even more innovative applications emerge.
Yeah, it's exciting to think about all the possibilities.
Yeah.
But for companies that are considering adopting the LPU, what are some of the challenges they might face? What hurdles do they need to overcome?
That's a great question. And one of the biggest challenges is integration. The LPU is still relatively new, so it's not always a simple plug-and-play solution.
Right, you can't just swap it in and expect everything to work perfectly.
Not quite. It often requires some level of customization and optimization to make sure it integrates smoothly with existing systems and workflows.
So there's a learning curve involved.
There can be, but the good news is that Groq has been really proactive about building a strong ecosystem of partners and support resources to help companies with this process.
Okay, so they're not just leaving companies high and dry.
No, they're committed to making the adoption process as seamless as possible.
That's good to hear. But beyond the technical integration, what other challenges might companies encounter?
Well, another challenge is talent. Finding engineers and developers who have the expertise to work with this new technology can be difficult.
So it's a specialized skill set.
It is, but again, Groq is actively investing in training and education programs to help address this. They're also partnering with universities and research institutions to nurture the next generation of AI hardware experts.
So they're thinking long term.
Exactly. They understand that for the LPU to truly succeed, it needs a thriving ecosystem of talent and support.
That makes sense. Okay, so we've talked about the benefits, the challenges, the use cases, but there's one more aspect we need to consider, and that's the economic side of things.
Right, the bottom line.
Exactly. We talked about the LPU's energy efficiency, but does it actually translate into cost savings for companies?
Absolutely. The LPU's energy efficiency can lead to some pretty significant cost savings, especially for companies that are running these really large-scale AI workloads.
So it's not just about being green, it's about saving green.
Exactly. When you're running massive data centers, Those energy bills can be huge, so even small improvements in efficiency can make a big difference.
Yeah, that makes sense.
Yeah.
So there's a strong business case to be made for the LPU.
Without a doubt. And as the technology continues to improve and energy costs keep rising, those economic benefits are only going to become more pronounced.
Okay, so we've covered a lot of ground here, but I want to zoom out for a moment and ask a bigger question. What does the rise of specialized AI hardware, like the LPU, mean for the future of computing as a whole? Are we witnessing a fundamental shift?
That's a really interesting question, and I don't think anyone has a definitive answer yet, but I do believe we're seeing a major transformation in how we design and build computers.
So it's not just about AI, it's about the future of computing itself.
Exactly. For decades, we've relied on these general-purpose processors like CPUs to handle all kinds of tasks.
Right, the one-size-fits-all approach.
Right. But as AI workloads have become more complex and demanding, we've kind of hit the limits of that approach.
I see.
We need something more specialized, something more powerful, and that's where hardware like the LPU comes in.
So specialization is the key.
I think so, and I think this trend is going to continue. We're going to see more and more chips designed specifically for certain types of tasks, whether it's AI gaming graphics, rendering scientific simulations, you name it.
It's like the Cambrian explosion of computing.
That's a great analogy.
All these new and specialized forms of digital life emerging.
Exactly. And I think it's going to lead to an explosion of innovation and creativity in the tech world.
It's an exciting time to be alive, that's for sure.
Right.
But it also makes me wonder about compatibility. If we have all these different specialized chips, how do we make sure they can all work together smoothly?
That's a great point, and it's a challenge that the industry is actively working to address.
Okay, good.
We need to develop new standards and protocols that allow these diverse chips to communicate and collaborate effectively.
It's like building a universal translator for the world of computing.
Exactly. And it's not just about the hardware, the software needs to adapt as well. We need programming languages and frameworks that can seamlessly target these different architectures.
So it's a multifaceted challenge.
It is. But I'm confident we can solve it. We're really good at figuring things out in the tech world.
Yeah, I agree. Okay, so this conversation has really highlighted the importance of staying curious and adaptable as technology advances. We need to be open to new ideas and challenge our assumptions about how things work.
I couldn't agree more. It's all about embracing the unknown and pushing the boundaries of what's possible.
Well said, and that's a great message for our listeners. Don't be afraid to explore the unknown. That's how we drive progress and shape the future.
Absolutely. Okay, so we've covered a lot of ground today, from the technical details of the LPU to the broader implications for the future of computing.
Yeah, it's been quite a journey.
It really has, but before we wrap up this segment, I want to leave our listeners with a thought-provoking question.
Okay, hit me with it.
If the LPU represents this convergence of AI and specialized hardware, what other convergences might we see in the years to come? What unexpected partnerships or innovations might emerge as technology keeps evolving at this incredible pace?
Ooh, that's a good one. It's something to really ponder, and we'll dive into those possibilities and more in our final segment, so stay tuned. Welcome back to the show, everyone, for the final part of our deep dive. It's been a wild ride.
It has been a lot to unpack.
It has. And in that last part, we were talking about like these potential convergences and these unexpected partnerships as technology evolves. Like, where do you see this going?
Well, I think one really interesting area to watch is the automotive industry.
Oh, yeah. Cars.
Yeah, we're already seeing the impact of AI in self-driving cars, right?
Yeah, for sure.
And specialized hardware like the LPU, it's going to be absolutely crucial for making those systems safer, more efficient, more reliable.
So you're saying like the LPU could be powering the brains of our future autonomous vehicles?
It's definitely a possibility, and it's not just about the cars themselves.
Right.
It's also about managing the whole infrastructure that supports autonomous driving.
Yeah, the traffic systems, the communication networks.
Exactly. All of that stuff has to work together seamlessly, and it's going to require some serious computing power.
So AI hardware isn't just about like individual devices, it's about transforming entire systems.
Exactly. It's about creating these intelligent, interconnected ecosystems, and I think we'll see similar transformations in other industries too.
Like where?
We'll take manufacturing, for example.
Yeah.
Specialized AI hardware could completely revolutionize how we design, build, and operate factories.
Wow, in what ways?
Well, we could see more automation, improved quality control, significant cost reductions. It's all about making manufacturing smarter and more efficient.
Oh, so smarter factories, more efficient production, maybe even like cooler, more innovative products.
Exactly. It's a win-win-win. And it's not just about efficiency and productivity either.
Okay.
This kind of AI hardware, it could also play a really crucial role in tackling some of the world's biggest challenges,
Really? Like what?
like climate change.
Oh, wow.
Yeah.
Okay, so how does AI hardware help us fight climate change?
Well, for one thing, it can accelerate the development of renewable energy technologies. It can help us optimize energy consumption in smart cities. It can even help us understand and predict climate patterns better.
So it's like giving scientists and engineers a superpower to fight climate change.
Exactly. And it doesn't stop there.
All right.
AI hardware can also be a game changer for healthcare.
Oh, yeah? Healthcare? How so?
Well, it could enable the development of personalized medicine, leading to more targeted treatments, better outcomes.
Yeah.
It could improve the accuracy of disease diagnosis, help us find new cures for diseases that are currently incurable.
That's amazing. It feels like we're on the verge of like a technological revolution that could really make a difference in the world.
I agree, but it's important to remember that with any powerful technology, there are always potential risks and challenges.
Right. This is not all sunshine and roses.
Exactly. We need to be thoughtful and responsible about how we develop and deploy these technologies.
Absolutely. Like we have to make sure they're being used for good.
Exactly. We need to have those open and honest conversations about the ethical implications of AI. We need to make sure that these technologies are used in a way that benefits all of humanity.
Well said. That's a perfect way to wrap up this conversation. I want to thank you so much for joining me on this deep dive into the world of AI hardware. It's been a really eye-opening experience.
The pleasure was all mine. It's always great to talk about this stuff.
And to our listeners out there, I hope this has sparked your curiosity and maybe even inspired you to learn more about the incredible world of AI and its impact on our lives.
Couldn't have said it better myself.
So as we move forward into this exciting future, let's all remember to embrace curiosity, approach innovation with a sense of responsibility, and never stop exploring the possibilities that lie ahead.
Here to the future.
And on that note, that's a wrap on another deep dive. Thanks for tuning in, everyone.